Lesson 4.2. Okay, quadratic equations. This one is going to be solving by the quadratic formula. Okay, so first we're going to talk about the discriminant. So the discriminant is going to tell you how many, and there's different words here because there's lots of different ways to describe what this is. Some people refer to them solutions, some people refer to them as x-intercepts, zeros, or roots. And when I say people, I really mean like questions. There's so many different ways questions will ask, like what are the x-intercepts? What are the zeros? What are the roots? So these are all the different words that a quadratic will have. Okay, so your discriminant is this formula, b squared minus 4ac. Okay. Now, what will you be doing with b, a, and c? You will be substituting in numbers based on an equation that you were given. So let's talk about what it will mean once you substitute those values in. So if your discriminant, b squared minus 4ac, is greater than 0. So when you substitute in the values, you square, you multiply by -4, do all the work. If that is greater than 0, that number that comes out, okay, you will have two real solutions. Okay, now we are going to come back and fill out some information on this. I was going to say chart, but it's not really a chart, but we're going to come back and fill out. So please leave a couple lines for some space to come back and write some more things because we're going to refer back to this. Let's do 3 lines. Okay. If your b squared minus 4ac, if your discriminant equals 0, if it comes out to exactly 0, that means you're going to have one real solution. X-intercept, 0, root, any of the words. Okay, and then lastly, if your b squared minus 4ac is less than 0, meaning it's negative, you're going to have two non-real solutions, or in other words, you will have no real solutions. Okay, so remember, real is in reference when you have, or sorry, non-real would be in reference when you have imaginary numbers. Okay, so let's do an example. Like I said, we are going to come back and fill out some information, so please leave some space for those 3. Okay. So the question we're going to do is how many solutions does y equals negative 2x squared minus 3x plus 5 have? Now, how does this equate to A, B, and C? Okay, well, we got to remember our standard form for equations, which normally we would have ax plus by plus c. That's our standard for linear equations. But our standard for quadratic is ax squared plus bx plus c equals 0. So rather than x and y, we have x squared and x to resemble quadratics. So therefore, in this scenario, a is going to be -2, b is going to be -3, and c is going to be 5. Okay, A, B, and C. So I'm going to substitute that in to my discriminant, which I do need to show. So B, I'm going to have -3 squared minus 4 times A times C. And again, this is a must show, meaning if you do not show that step, you do not get credit for the answer. Okay, now from here, you can go ahead and substitute that whole thing into your calculator. So using our parentheses, we have parentheses -3 squared minus 4, parenthesis, negative 2, parenthesis 5. Go ahead and show how I type that in. Looks exactly like this. Hit enter, and you should get 49. So it equals 49. Okay. From here, you're going to do a comparison of your number based on the three options, which was greater than 0, equal to 0, or less than 0. So 49 is greater than 0, which is a must show because you're showing your comparison. Therefore, which I'm going to teach you a little symbol, therefore, which is 3 dots. It's just a fancy way of 3 dots. Therefore, because it's greater than 0, we know that there are 2 real solutions, which is again a must show. We have an extra little curl on that. Must show. Okay, so really the only thing you could do to simplify this is that you could say it equals 49 and you could do your comparison right from there. Okay, but again, this is what we know about the discriminant. The equation is b squared minus 4ac. And if it's greater than 0, we have 2 real solutions, and we'll fill in more information. If it's equal to 0, that means it's 1 real solution. And if it's less than 0, you would say that it either has 2 non-real solutions or no real solutions. And this would be an example of figuring out how many solutions a quadratic has by substituting A, B, and C based on the standard of a quadratic formula, substituting in, showing that substitution. Go ahead and you can put that in your calculator, compare it, either being greater, equal, or less than 0, and then showing the result of that being 2, 1, or no real solutions. Okay, let's go ahead and go to the next type of question. Because that one is so kind of straightforward, we're going to move on. Okay. Okay, so the next part of what we're going to be doing is solving by the quadratic formula. Now, you don't know what the quadratic formula is yet, but little do you know, there is a song to go along with it. And if we were in the class, I'd be singing it to you. And I'm still gonna sing it to you, but we'd be singing it together, which we'll see how that goes in our next class session. So let's remind ourselves of the standard form of a quadratic formula. So, not formula, quadratic equation. So therefore the quadratic formula is as follows. Now I'm just going to simply write it this time, but then I will sing it for you. So it is x equals, remember that, sorry, I was going to say something, remember, but I was talking about the discriminant. Remember that x-intercepts, solutions, they all mean the same thing. So when I say x equals, that's where that comes from. So x equals opposite of b, or negative b, plus or minus the square root of b squared minus 4ac. Hopefully you recognize that from the discriminant. All divided by, whole thing, 2a. So x equals the opposite of b plus or minus the square root of b squared minus 4ac, whole thing divided by 2a. Okay, down to singing time. So the song is from the quadratic formula, sorry, the song of the quadratic formula is set to Pop Goes the Weasel. So it's normally a song like in the Jack in the Boxes, like the toys. So let me sing it for you. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. I'll do it again. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. And so that is a song. I've learned that since I was in 8th or 9th grade, or whenever I learned the quadratic formula, probably 9th or 10th. And almost all teachers know it. There's lots of YouTube videos about it. There's more contemporary songs as far as with better beats, as far as not just Pop Goes the Weasel. Lots of songs on YouTube if you would rather find a different tune to memorize this. But that's probably the most common, Pop Goes the Weasel. So with that, we're going to learn how to solve using the quadratic formula. So my instructions are to solve each equation using the quadratic formula. State exact answers. And rounded real solutions to the nearest hundredth. Okay, solve each equation using the quadratic formula, so not by factoring like we learned last time. State each equation, excuse me, and the rounded real solutions to the nearest hundredth. So you're going to be stating answers in two different ways, the exact answer and a rounded answer. So number 1, 2x squared minus x minus 4 equals 0. So much like the discriminant, you're going to take A, B, and C, and you're going to substitute it for the formula or for the equation. So therefore, in the scenario, A is 2, B is -1, and C is -4. And so I'm going to substitute those three numbers, or sorry, those three numbers for all those variables into the formula. So x equals opposite of B, so that'd be +1, plus or minus the square root of B squared minus 4AC. Make sure your square root extends out. Sometimes it doesn't when you initially. Whole thing, including the opposite of B, whole thing divided by 2A. Okay, so this is the first step, and this is a must show. Okay, you got to show that you substituted everything in. Then from there, you can simplify the discriminant. So on the inside, you can go ahead and substitute that in just like we did on the previous problems. So I have parenthesis -1 squared minus 4 times 2 times -4. Again, it looks very similar. Hit enter, and I get 33. So I can simplify the whole thing to 33 divided by, now this time I drew the too long, so I just erase that. And then you can multiply the bottom, 2 times 2 is 4. Okay, which you must show. So from step 1 to step 2, all you're doing is simplifying the discriminant, which is under the radical. So what are my answers? So your exact answer, which exact answer means that there's no estimating whatsoever. It is what it is. It's as precisely as what is written. So your exact answer would be 1 plus or minus the square root of 33 divided by 4. Okay, this is your exact answer. Now you also need your rounded answers. So how do you find your rounded answers? Well, you find your rounded answers by putting in your calculator. So you have 1 plus the square root of 33 divided by 4, and we'll figure out what that's approximately. And we have 1 minus the square root of 33 divided by 4, approximately. So we're going to put that in our calculator. So parenthesis 1 plus the square root of 33 divided by 4. Now you have to use parentheses outside like I wrote it, okay? Or it's going to just divide by 4 and then add 1. We need to add the 1 and then divide by 4. So make sure you have your parentheses and you should get approximately this. Now we're rounding to the hundredth. Hundredth is the second place. So we look at the third number to see if we need to round up. 6 is higher than 5, so therefore the 8 rounds up. So this is approximately 1.69. Okay, now if you don't remember a fancy trick, you can hit second enter. It types the whole thing again, and all I have to do is arrow over and make this a subtraction sign, not a negative sign, a subtraction sign. Hit enter, and I get approximately negative 1.19. So this is my rounded answers. Okay, and that's number 1. Okay, let's go ahead and we have number 2 and number 3. Number 2, oh, I guess I didn't number this problem. I was like, hey, this is our third example. My bad, sorry. Okay, number 2 on the quadratic formula, I guess. X squared plus 6x equals negative 9. Okay, now similar to when we are solving by factoring, you have to set it equal to 0 to work, much like the equation that we wrote out here. It has to be equal to 0. So therefore, x squared plus 6,9 plus 9 equals 0. And identify A, B, and C. A is 1, B is C. Sorry, B is 6, C is 9. Okay, and then we put it in the formula. Now, what was that formula again? Let's sing it. Opposite B plus or minus the square root of B squared minus 4AC all over 2A. So therefore we have opposite of B, so X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. Okay, so you can sing it to yourself while you're filling in the information. And again, this is a must show. And then we go and simplify negative 6 plus or minus the square root. I'm going to substitute in that information. Parentheses 6 squared minus 4 times 1 times 9. Now this one's a little easier. You can probably do it in your head. This one comes out to be 0. It comes out to be 0. And 2 times 1 is 2. Well, what is the square root of 0? Square root of 0 is 0. So this simplifies to be negative 6 plus or minus 0 divided by 2. Well, if you add or subtract 0, that really doesn't do anything. And so we get negative 6 halves, or in fact, we get negative 3. Now, how did that happen? Well, if we go back to looking at our discriminant information, do you see how when it equals 0, we get one real solution? Well, because it equals 0, you end up with just one nice answer. So therefore, x equals -3, and there would be no approximate answer on this one because it is just 3. Okay, no approximate value, no rounded answer. Okay, let's go ahead and try the third one. -3x squared plus 4x minus 3 equals 0. So A is -3, B is 4, C is -3. So substitute in my information. So I'm going to sing it again. X equals opposite of B plus or minus the square root of B squared minus 4AC. Takes a second to write that. All over 2A. Okay, again, a must show. Second step, simplify my discriminant, plus or minus square root 4 squared minus 4 times -3 times -3. I get -20 divided by -6. Now, -20 can simplify. In our first example, we got 33, which we didn't really discuss, and that's kind of my bad. We didn't discuss that one can't simplify. There's no perfect factor that can. But we do know that 20 has a perfect factor. It also has a negative in there, which means that we're going to have imaginary numbers. So we need to show the step of simplifying that. So we have -4 plus or minus the square root. So we pull out the negative, and then we pull out our factor of 20. That's a perfect square, which is 4, which leaves us with 20. So then -4 plus or minus, well, square root of -1 is I, square root of 4 is 2, so we have plus or minus 2I, square root of 5, all divided by -6. And from here, we should notice that all of the outside numbers are divisible by 2. Each of these is divisible by 2, so I can divide the whole thing by 2. And so therefore I get -2 plus or minus I square root of 5 divided by -3. Which is good, but we don't like when we have leading terms being negative. So instead of having both of those being negative, I'm going to go ahead and simplify by a -1, which impacts, or sorry, yeah, which only is going to impact the -2 and the -3, which will give us a final answer of 2 plus or minus I square root of 5 divided by 3. Now, the reason why it only impacted is because if I divide by a negative, well, it's plus and minus. So you're still going to have both options of plus and minus. Right? So here's our exact answer. I just realized that I've been talking this whole time. It was muted. Oh no. Okay, let's try that again. So, number 3. I'm so sorry. I'm going to cut it out. Hopefully. Okay, number 3 we have here. You will not have any approximate answers for this one either because you cannot approximate an imaginary number, but we'll talk about that a little bit later. So let's reflect back on the discriminant. So the discriminant has 2 real solutions because it has a positive number under the radical, which is like example number 1. Okay, we had 33, so therefore here's our exact answer and here's our rounded answers. Then we have equal to 0. So equal to 0 is when you have a 0 under the radical and you only have one real solution, which was like example 2. Okay, like example 2, it was equal to 0, so therefore we had one real solution. And then last but not least, we have when it is less than 0, meaning you have a negative number under the radical. Which is like example number 3. So there are technically 2 non-real solutions or no real solutions, and that is simply because we have the imaginary unit. Okay, all right, so those are your notes for 4.2 or for solving using a quadratic formula. I hope you enjoyed the singing and good luck on your assignment.